All right, geometry. So here we go to finish standard 4. We have dilations today. Okay, in class 12, we talked about translations. In class 13, we talked about reflections over the horizontal and vertical lines. In class 14 yesterday, we talked about rotations about the origin at 90 degrees, 180 degrees, and 270 degrees. And so today we wrap it up with dilation about the origin. Okay, so any two of those that you can apply coordinate rules to transform figures in any of those two ways will put you at the 1 for the standard, the beginning level. Being able to use any three of the 4 puts you at approaching proficiency, and being successful with all 4 ideas will put you at proficient. Okay, a level 4 exemplary means that you can describe the transformation that maps a given pre-image to a given image and provide a pre-image point if given the image. So that means you're going to be able to work backwards. Okay, so those are the 4 on the scale. So let's look specifically today at dilations. Okay, classify each of the following pre-image images pairs as either a reduction or an enlargement. That's what dilations are. Specifically, it's either a reduction or an enlargement. So if we look at triangles STR and S prime, T prime, R prime, what happened? Okay, again, we know that this is the image and this one's the pre-image because of the little symbolism that we have here. So we would say that this is a reduction, right? It got smaller instead of larger. So we say that this is a reduction. Okay, looking at the next example again, you have to pay attention to which one's the image, which one's the pre-image. We know here it's the pre-image by the symbols. We know that this is the image. Okay, what happened from the pre-image to the image? We had an enlargement. Okay, and then on the last one with WXYZ to W prime X prime Y prime Z prime. Okay, so from the pre-image to the image, what happened here? We had another enlargement. Okay, those are both dilations. Whether it's a reduction or enlargement, the general term for that is a dilation. Okay, made it bigger or smaller. So let's put words to the vocab for dilation. We say a transformation that changes the size of a figure according to a scale factor, which we haven't talked about yet, but we'll get there. Okay, so how much bigger, how much smaller is what that means. And a center of dilation. To complete a dilation about the origin, you will multiply all coordinates by the scale factor. Dilations can be, we already discovered this, reductions if the figure gets smaller, or enlargements if the figure gets bigger. Okay, so a scale factor of 2 is going to do what to it? It's going to enlarge it, right? Scale factor of 1/2 is going to make it smaller or reduce it. Okay, so here we go. I'm going to zoom in here for the examples now. Okay, if the pre-image for triangle ABC is given, okay, we're asked to use the pre-images below and given the instructions, which are given for each, dilate the pre-images, so either reduce or enlarge, and label the images appropriately. Okay, so again, as I did earlier, I'm going to start by identifying the ordered pairs of the pre-image. Okay, so if n is 1/2, that means we are reducing by 1/2, which means we're going to multiply all of those coordinates by 1/2. So we get b multiplied by 1/2, I get 1/2 and 3. So b prime is at 1/2, 3. Okay, a, half of both each coordinate is going to be -3, positive 4.5. And I don't care if you use 4.5 or 4.5, they mean the same. Half of coordinate C is going to be negative 3.5, 2.5. There, I use sum of each. Use the mixed number as well as the decimal, so you see clearly that it's okay as long as the decimal terminates, which it does. Okay, next. And that's what we're doing today. So again, anytime you feel good, pause it, do them, complete each of the examples, and then hit play and fast forward to check to make sure that they're good. Okay, give my coordinates here. 6, 1, wait, 3, 1, sorry, 3, 1. Negative 4, positive 4. And then negative 5, 0. Okay, so that's my pre-image. N equals 2, so what's going to happen here, we're going to enlarge, so we're going to double everything. So 6, 2, it's going to be in the way, so 6, 2 is my B prime. If I double here, I get negative 8, positive 4. I'm sorry, that's at 4, 4, so negative 8, positive 8. A prime is at negative 8, positive 8. Doubling it makes it negative 10. Grab my straight edge here. And then finish it up. And we are done. There is my enlarged image with labels. Okay, next one, my pre-image. Pointer at 8, 1, 1, 4, and C is at 0, 0. Okay, and is 3/4. Okay, it's all right. You got this. Fractions and aren't everybody's best friend, but you're okay. So it's 3/4 going to enlarge or reduce. Still going to reduce, right? So at 3/4 for A, we're at 3/4, 3. Okay, 0, 0 stays. 0 times anything stays 0. 3/4 of 8 is 6. 3/4 of 1 is 3/4. So 6 and 3/4 is my B prime. So it's going to be hard to see this one around. So slightly reduced. Okay. Good. Last two. Last one, and then we're going to see if we can go backwards. So we were given the pre-image and the image, and we're going to figure out if we can go back and get what the n value is. Okay, so to start with, let's get our ordered pairs down here. So we've got negative 2, 3, negative 1, negative 1, and negative 3, negative 1. Okay, then let's go look at what we're going to do. N is 3. So what's going to happen here? It's going to get a lot bigger, right? Quite a bit bigger, 3 times bigger. So negative 6, 9. Is L prime, negative 6, 9. Okay, multiply by 3, I get negative 9, negative 3. M prime. Okay, multiply by 3, I get negative 3, negative 3. So P prime is negative 3, negative 3. And that completes our image there. All right, so can you do a level 4 with dilations? Describe the transformation that mapped the pre-image to the image. So again, I would start with, let's look at what our ordered pairs are. So L is at -2, -1. M is at -4, -4. And P is at 0, -4. Okay, so let's see what happened to go to L prime. Well, -4, -2. M prime went to -8, -8. Okay. And P prime went to 0, -8. Okay, so again, I would show this work. It shows me clearly how you're going to get your answer. So what transformation is done? It is a dilation, which we knew, right? Changing the shape with n equal to what happened. What do we do with every coordinate in the pre-image to get to the image? Multiply by 2, right? Okay, so lastly, let's do as we've done each of the previous days. Okay. It says for each of the examples above, compare the pre-image to the image, summarize the effects of a reflection below. A dilation does or does not change the size of the pre-image. It does change the size, right? That's a definition. It reduces or enlarges it. A dilation does or does not change the shape of the pre-image. Should it change shape? No, these were all triangles. They say triangles. And it does or does not change the location of the pre-image. Did it change where it was to start with? Absolutely did. Okay, and that is our work on dilations. So you are now hopefully able to go ahead and complete homework 15.